Hey guys, here are notes for section 9.3. Hopefully you printed out a copy of them off the website and you can just fill in the blanks. 9.3 is about chords and arcs. Now here's a circle. Center of the circle is P. And if you draw in two radii from that center point P, you'll get an angle in the center. We call that a central angle. And central angles are always equal to their arcs. So let's say this angle was 90 degrees. Then this arc would be 90 degrees out of the whole 360 degrees that the circle is. This arc would be 90 degrees since the central angle is 90 degrees. Central angles are equal to their arcs. Now a couple of vocab terms. We have what we call a minor arc, which is an arc that's less than 180. 180, right, is straight across. If this is 90, then 180 would be half a circle. A major arc is going to be an arc more than 180, and you have to use 3 letters for a major arc. If you only see 2 letters when you're saying arc AB, then you'd be doing the minor arc. If you're saying arc ACB, then you'd be talking about this major arc in the back. So that must have 3 letters for a major arc. And a semicircle is what I said was half a circle. Semi really means half here. An arc where the endpoints. Okay, it's when the endpoints are on the diameter of the circle, then it's going to equal 80 degrees. So if point A and you came straight across and made a complete straight line over here, that would be a diameter, and then your semicircle would be half of that. And it's technically a major arc, but major arcs usually we call them more than 180. If it's exactly 180, we'll call it a semicircle. All right, let's do example 1 here. What is the measure of arc AB? So if the angle is 60 degrees, the arc also has to be 60 degrees. So this arc right there, arc AB, is a 60-degree arc. As we move down, BC, this arc right here is exactly half of a circle. It's a semicircle, so it would be 180 degrees. Now, a 180 degree arc, you can use 2 letters or you can use 3 letters. It doesn't matter because it's going to be equal to or less than 180, you can use 2 letters. Only when it's more than 180 do you have to use 3 letters. Now notice this one is arc ACD, from A to C to D, which is greater than 180 degrees. So you're going to see that this one is going to equal 230 degrees, and it's going to be this arc that comes all the way around here past half a circle. So that's arc ADC, that's 230 degrees there. All right, moving on, you can pause it if you need to. Example 2, find the measure of each arc. All right, so arc GE. So from G to E would be 40 degrees plus 80 degrees. It's this whole arc right here. So 40 plus 80 is 120 degrees. GEF is 3 letters. That's telling me that it's going to be more than 180 degrees. G through E all the way to F. So it's the 110 plus the 80 plus the 40. So you've got 120 here plus another 110. From G to E to F is going to be 230 degrees. GF, 2 letters. Looking for a minor arc from G to F back this direction. Well, if we know that this whole thing is 230, and we know the circle complete all the way around adds up to 360. So we've got 360 minus this 230 from it. You're going to end up with 130 degrees for this back arc right here. And if you want to on your paper put in 130 right here, you know, that would be fine, because you can notate to yourself that this right here was 130 degrees. All right, moving on here. Let's look at the next topic. It says, what can we say about arc AB and arc BC, and what do we know about line AB and line BC? Well, segment or chord AB is congruent to chord BC. So if this chord equals this chord, that means it has to cover the same amount of the circle. So that means this arc AB is going to also be the same as arc BC. So the arcs would also be congruent. So what can we say about it using if and only if? Well, here it is. two arcs are congruent, two arcs, arc AB is congruent to BC if and only if their chords are also congruent. So if the two chords are congruent, in other words, if the two chords are congruent, then you're going to have congruent arcs. Congruent chords makes congruent arcs, and vice versa. Congruent arcs would also make congruent chords. It's intersecting the same amount of the circle. That's why it's congruent. Radius and chord properties. The perpendicular bisector of any chord. So you see this chord DF right here? If I'm perpendicular and I'm bisecting it, then it must contain the center of the circle to do that. The only way that I could be cutting this chord exactly in half and making it 90 degrees is if I went through the center point. That means it's going to either be a radius or a diameter, because that's the only way it could go through the center. So perpendicular bisector of a chord must contain the center of the circle. Anytime a radius or a diameter bisects a chord, it has to be perpendicular to that chord. So if it's bisecting it and perpendicular, that means it's got to contain the center of the circle. You can pause it if you need to. Okay, we can apply these central angles that we just learned with circle graphs, because you should always make a circle graph to where it makes sense. So let's make a circle graph using this data. Okay, so we've got, let's see, I think that's the wrong one. Okay, so this needs to go down here, down here. Okay, so 75 out of 500 students, there's 500 total. 75 of those students are freshmen out of 500, that's a 15%. And let me move these all down. So this is going to come down to here. Here's my percent. And here's my degrees. Okay, so 15% of 360 means you're going to need a 54-degree angle. 100 of 500 would be 20% of those are sophomores. 20% of the total are sophomores. So 20% times 360 would be me a 72 angle, 72-degree angle. 145 are juniors out of 500. That means 29% of these students are juniors. 29% out of the total 360 would be 104.4 degrees. And then there's 180 seniors out of 500 would be 36%. And we have 129.6 degrees. So then you would draw in your angles and you would measure them. Like this angle right here would be a 54-degree angle and it's freshman. Now I wouldn't put 54 degrees on my circle graph. What I would put is 15%, or I would just put the word freshman. 72 degrees and our sophomores, which would be 20%. 104 degrees would be juniors, or I would put 29%. And then we have seniors are 130 degrees, which would be about 36% are seniors. So that would be how you apply the degrees, your percent out of 360, and you get your central angle. Central angle has to equal the amount of degrees for that. I could have sworn I had something else in here. Yes, I did. There it is, 100% and 360 degrees when you add it up. All right, example 4. You're designing the following logo. This is going to be your new logo. What is the radius from O to B? What is the radius? Well, we know that from E to B is 2. They gave us that down here. Well, they gave us from E to C is 4. And same thing with A to E. And they gave us this piece as radical 80. So we want to find the radius containing the logo. So we need to use Pythagorean theorem because we have a right triangle right here. Because of the right triangle, Pythagorean theorem would work. So let's see what that looks like. DC squared would equal DE squared plus EC squared. So you basically have C squared equals A squared plus B squared. And so plugging in the numbers, here's your C squared. And you have DE, we don't know yet. We do know that EC is 4. So we we square everything. The square and the square root cancel out there. 4 squared is 16. And then subtract 16, you're going to get 64. Square root both sides. You're going to get DE is 8. So this D to E is 8. That's this leg right here. Now, that's not the radius. It's just this leg from D all the way down to E. It's 8. Now, we do know that DE, D to E, plus EB is a diameter. So that whole thing would be the diameter. So basically, we have the DE, which is 8, plus the 2 equals going to be our whole diameter is a 10. The whole diameter is 10. That means that if you take 10 and cut it in half, your radius is going to be 5. So you'll have a radius of 5. So that's example 4 there. Using Pythagorean theorem and then just using our logic to find the diameter and then dividing it by 2 to get the radius. Arc length. Arc length is the measure of part of the circumference. So if you want to find a part of the whole circumference, just how long is this piece, if you were to cut this off here and straighten it out and measuring it on a ruler, how much would that piece be? To find arc length, you multiply the percent you want by the circumference. The whole thing is the circumference, and you just multiply by the percent that you want of the whole circumference. So arc length is going to be this fraction. That's going to be the part that we want out of 360. The piece that we want out of 360 times the entire circumference. That's going to tell me how much the arc length is. This percent is going to be less than 1, so it's going to be less than the whole circumference because you only want part of the circle. You don't want the whole thing. So if we want to find the arc length of AC here, the arc length of AC, you're going to need the part times the circumference. So the arc length is going to be 60-degree arc out of the whole 360. And then we're going to change that to 1/6. And 2 times 6 is going to give me a 12. Now you could cross cancel here, make this a 1 and a 2. So really you're just going to get 2 pi, which means your arc length is really 6.28 centimeters. So from here to here is a little bit longer than the radius. It's going to be 6.28 centimeters. Now that's it for 9.3. Don't forget your practice problems. You need to get the practice problems done. Just pause it on there and get them done or do them on your notes. And we'll see you guys later.